Solution to determine vehicle density through camera system Hoang Ba Nghia. Abstract. Currently, the smart traffic system is one of the top development priorities for Vietnam to build smart cities across the country. Traffic situation in big cities in Vietnam has become a problem for road users during rush hours. Local congestion has occurred on many roads. Reducing congestion in big cities is an urgent issue. Therefore, in this paper, we propose a solution to determine vehicle density, to warn traffic congestion through the city camera system. Keywords: it's, deep learning, FCN, warning of traffic congestion. Introduction. Currently, solving traffic congestion in developing countries is an urgent issue. Studies of camera application to determine speed. 1, 2. AI. Artificial intelligence is the science that makes machines intelligent, with the ultimate goal of allowing robots to possess the human-like capabilities. In fact, AI has had a significant impact on our lives, in ways that improve human health, safety, and productivity. For example, face recognition via video. 3. The deployment of AI technologies is important to promote the scope of IoT. AI technologies are highly customized for individual tasks, and each application requires specialized research and structure. Deep learning, a form of machine learning based on trained data sets, has facilitated advanced pattern recognition in images, video, and object/activity recognition. Its algorithms can be widely applied to an array of applications that rely on pattern recognition. Therefore, in this paper, we apply deep learning to analyze images from traffic cameras to determine the vehicle density participating in the traffic. Providing support information about the current traffic situation to road users to know the situation of congestion on roads in big cities in Vietnam. The works we have contributed in the paper include: proposing an algorithm to determine vehicle density through images captured directly from traffic cameras. Building a server system to store warning data. The remainder of the paper is organized as follows: Part 2. Presentation of related works. Part 3. Development of the experimental system and its results. Conclusion and future development direction in Part 4. 2. Related works. A. Semantic segmentation. Semantic segmentation is the process of converting digital images into simple images or representations into something more meaningful and easily analyzed. Specific key steps. 1. Finding out the central points of the objects, including making predictions for the input image. 2. The next step is to locate/detect, provide not only live names of objects at each central point but also provide additional information related to the location of the object. 3. Finally, semantic segmentation provide detailed results from the object name predictions of each pixel, so that each segmentation is assigned a corresponding object name. The general technique when building the network for this problem is to build a model of two components of the encoder and decoder. In particular, the encoder is to reduce the length and width of the image using the convolutional and pooling layers. The decoder is used to restore the original image size. The encoder is usually just a regular CNN but removes the last fully connected layers. The available networks can be used in the encoder as VGG16, VGG19, AlexNet, MobileNet, and the decoder depending on the network architecture can be built differently. For example, in FCN. In FCN architecture, there are three ways to build a decoder to form three different types of FCN: FCN32, FCN16, FCN8. For FCN32, after reaching the final pooling layer, the above example is the fifth pooling layer, just upsample to the original size. For FCN16, at the fifth pooling layer we multiply 2 times to get the size equal to the size of the fourth pooling layer, then add 2 layers together and then upsample to the original image size. Similarly with FCN8 we connect to the third pooling layer. Basic concepts in semantic segmentation model. In a regular neural network, from the input, go through the hidden layers and then output. For CNN, the convolutional layer is also a hidden layer, but the convolutional layer is a set of feature maps and each of these feature maps is a scan of the original input, but extracted to specific features. The scan results depend on the values inside the kernel. This is a matrix that will scan the input data matrix, from left to right, top to bottom, and multiply corresponding values of the input matrix into the kernel matrix and then sum it up, giving via activation function, sigmoid, relu, elu, the result will be a specific number. The set of numbers is another matrix, which is the feature map. Stride is the distance between the two kernels when scanning. With stride equals 1, the kernel will scan two adjacent cells, but with stride equals 2, the kernel will scan cell 1 and cell 3. Ignore the middle box. This is to avoid duplicate values in the scanned cells. The larger stride and kernel size is, the smaller the size of feature map is, partly because the kernel must be completely in the input. There is a way to keep the size of feature map unchanged. This is padding. When adjusting padding equals 1, which means that we have added a cell around the edges of input, the thicker the wrap is, the more padding will be needed. The gray part is the additional wrap to the input. With stride equals 1 and padding equals 0, from the initial input image, scan the kernel and form the following cells to map into feature map. The purpose of pooling is simple, it reduces the number of hyperparameters that need to be calculated, thereby reducing calculation time, avoiding overfitting. The most common type of pooling is max pooling, which takes the maximum value in a pooling window. Pooling works almost like convolution. There is a sliding window called pooling window. This window slides through each value of the input data matrix, usually the feature maps in the convolutional layer. Select a value from the values in the sliding window. With max pooling we will get the maximum value. Transposed convolutional layer is a transformation in the opposite direction to convolution, capable of mapping for a larger size result. Suppose that we want to increase the denominator of the 2x2 input matrix into a 4x4 matrix that transforms through a 3x3 kernel as follows. Arranging the values of 3x3 kernel into 16x4 matrix and 2x2 input matrix into 4x1 matrix. Rearranging the values of matrix multiplication results, we obtain a 4x4 matrix. 3. System deployment. A statistical storage block. Creating MySQL database with the following structure. Density table, store density values and traffic status at a given time. B. Determining the density. In general, the status of the intersections is reflected through the functional area of the branch leading to the intersection, including the situation of traffic congestion. A congested intersection will result in congestion at the inlet branches. Therefore, studying the status of the functional area on the inlet branch can give us necessary warnings about traffic conditions at the intersection. Determining the road segmentation is the remaining part of the road/lane segmentation model. The percentage encroaching on the road of the vehicles will be saved the smallest and largest value in a light cycle from which to determine the difference value. See system training results. The model is trained with the Kitty Road Database 6 for the road/lane detection problem with over 500 images with corresponding segmentation images. Optimizing the model using cross-entropy to find loss function and optimizing by atom algorithm 7 to obtain the results in both dropout cases of 0.5 and 0.75. D. Experimental results. After the image data obtained from the traffic camera was applied through the software system that our team had developed, the result of the covering density is analyzed as figure 14. Based on the result of the percentage of density covering the vehicles on the road over time, the system will issue a warning to road users. For conclusion and direction for prospective development. In this paper, we have built a system for warning congestion through the traffic camera system. In the coming time, we propose a solution to guide the road users to avoid congested intersections.